Even though the stars in the night sky may appear unchanged to you each day, they are actually teeming with activity constantly. Somewhere, a cold gas cloud might be violently swirling, giving birth to a new star, while elsewhere, an old star might be exploding into a supernova. A black hole might be slowly radiating particles, or two black holes might be merging into a massive one, emitting gravitational waves that travel across vast, unimaginable distances. However, galaxies aren't good at preserving history. Like waves erasing sandcastles on a shore, the evidence of these stellar wonders emerging and vanishing is swept away by the sands of time in our universe. For a long time, an extraordinary marvel has been right before our eyes without us realizing it. The super-luminous and devastating quasar. Recently, the James Webb Space Telescope discovered the most distant pair of colliding quasars, each capable of obliterating an entire galaxy. Can you even grasp the magnitude of this discovery? Stay with us to understand how these colossal forces of destruction unleash their power. But first, let's delve into what quasars actually are. What are quasars? A quasar is the extremely luminous nucleus or core of a galaxy which is powered by a ravenous supermassive black hole. When a supermassive black hole at the heart of a galaxy is actively gulping down the stars and dust around it, you get a quasar. A supermassive black hole can weigh millions to tens of billions of times the mass of the Sun. First discovered in the late 1950s in radio surveys, quasars emit strongly at radio frequencies, unlike regular stars. Regular stars have almost zero emission in radio wavelengths, and since these radio sources were point sources and not smeared out like a galaxy, they were given the name quasi-stellar radio sources, star-like objects which emit radio waves, which later got shortened to the less unwieldy quasars. Although black holes are themselves invisible, they put quite a show using the material surrounding them that they are gorging on. Yes, we are talking about their accretion disk. As more and more star meal keeps piling up around the black hole, extreme heat is generated due to the friction, and you get a glowing accretion disk. In fact, black holes are the most efficient engines converting mass into energy. But talking about quasars, how much do they eat? A typical quasar can polish off mass equal to 100 Earths in a minute, and the more they eat, the more they glow. That makes quasars some of the brightest and hottest objects in the universe. A typical quasar would emit thousands of times more light than the entire Milky Way. That is why, even after being so far away, they shine so bright in radio light. The size of a quasar in comparison to the galaxy at the center of which it spins is analogous to a grain of sand relative to the Amazon River. And yet, their antics declare to the universe who the boss is, or may we say, where the center of power lies. They hold power to kill an entire galaxy. And how is that? Stick around to know more about this. The nearest quasar we know of is in the galaxy Markarian 231, at a distance of 600 million light-years from us. The farther away an object is, the older it is, because it takes that much time for the light from that object to reach us, given the finite speed of light. Most of the population of quasars is 10 billion light-years away, that is, at least 10 billion years old. Some quasars release jets perpendicular to the plane of rotation of the accretion disk, like a particle accelerator. They're like thunderous monsters screaming into the infinite void of our black, beautiful universe. How are quasars galaxy killers? Coming back to the question of how quasars came to spread their reign of terror as galaxy killers, what happens is that stars form from cold gas. Quasars, being among the brightest and hottest objects in the universe, make the gas around them so hot that it will eventually prevent any star formation in the galaxy, killing the galaxy in a way. In addition, a quasar also pushes gas out of its host galaxy into the jet, starving the galaxy, and whisking out material needed to form stars in the galaxy. James Webb Space Telescope discovers colliding quasars. You can imagine the mayhem that is unleashed when two black holes collide. Coming back to the latest research on quasars recently, the formidable James Webb Space Telescope spotted the most distant and the oldest collision of supermassive black holes or quasars. These two supermassive black holes are at the heart of merging galaxies. This black hole collision in the galactic region ZS7 is so distant that we can see it as it happened just 740 million years after the Big Bang, when these galaxies were just babies. Now that is one hell of a violent pair of baby galaxies, spiraling speedily into one another, merging into one humongous abyss, sinking into the center of their new merged galaxy, kicking up dust and stars in all directions. It would be one hell of a sight to see this cosmic clash of the titans. But a lot is yet to be known about quasars. Are quasars one of the phases in a galaxy's evolution? Or put another way, do all galaxies go through a quasar phase at some point in their lifetime? Or can only some specific types of galaxies host a quasar? Research is still ongoing to unravel the answers to these puzzles. The supermassive black hole at the center of our Milky Way galaxy, the Sagittarius A asterisk, is dormant, and consequently its accretion disk is too thin and faint for it to qualify as a quasar. That is one more enigma of the universe which makes life possible on Earth. Because a quasar that close could have emitted enough high-energy radiation to burn the Earth sterile if its jet was directed towards us. And if its jet was not towards us, then we could have got another source of light as bright as the sun in our skies. The many unique factors that make life possible on Earth sometimes make me wonder if the universe is a meticulous design by someone, as if in a simulation. Maybe Sagittarius A asterisk was once a quasar and has had its fill in the past. Or perhaps it will turn into a quasar in the future. Who knows what the tide brings? Perhaps when the Andromeda smashes into our Milky Way in about 4.5 billion years, these old, ravenous, and extremely luminous abysses won't go gentle into that good night. Share your thoughts in the comments section below, and be sure to subscribe to the channel for the latest revelations in space exploration. Hit the bell icon to stay updated, and let's continue to explore together.